In example 4, we are interested in determining our node voltages via node voltage analysis. We will follow our standard 4-step procedure. Step 1 is to assign nodes A, B, and C as designated in the diagram, where C corresponds to our ground, as well as our light currents, where I1 runs through a 6 ohm resistor, which is between nodes A and C, and I2 runs through our 3 ohm resistor, which exists between nodes B and C. Step 2 is to assign our voltage potentials consistent with our passive sign convention, where V1 corresponds to our 6 ohm resistor and its polarity is dictated by the directionality of I1, and V2 corresponds to a 3 ohm resistor where its polarity is dictated by the directionality of I2. Step 3 is to apply N, our number of nodes, less unity, less our number of voltage source, KCL equations, to our system. We have 3 nodes and 1 voltage source. Thus, we are going to apply 1 KCL equation. And since we have a supernode, we will apply our KCL equation to said supernode. If we apply our KCL equation to the supernode, we have the following. We have 1.5 amps entering, and we have I1 and I2, as well as 3.5 amps exiting. Step 4 is to apply Ohm's law in terms of our node voltages. Thus, we can re-express our KCL equation as follows. We still have 1.5 amps entering, whereas I1 exiting can be expressed as VA less VC per 6 ohms, where VC is equal to 0 volts, plus the 3.5 amps exiting through our current source, plus I2, which can be expressed as VB less VC per 3 ohms, where VC is equal to 0 volts. If we look at our supernode, we can construct a following equation. That is, 12 volts is equal to VB less VA. Or you could think about VB is equal to VA plus 12 volts. We see we have 2 equations and 2 unknowns. Thus, if we re-express our KCL equations in terms of VA and VB, we have the following. VA times a quantity of 1 per 6 plus VB times a quantity of 1 per 3 is equal to minus 2. We also have our supernode equation. If we put this in matrix form, we have the following. 0.16 repeating VA plus 0.33 repeating VB is equal to minus 2, and our supernode equation has minus 1 VA plus 1 VB is equal to 12. Thus, solving for VA and VB, we see VA is equal to minus 12 volts and VB is equal to 0.